Y'all are probably clapped out by now, I would assume. But if you would please allow one more for Tim, Rob, the Asante family, and everything, and also for their agreement to stop talking so that we could do this now. Please join me. One more round of applause. That was a lot of words. Before we start, let me put the TAIGR on the screen if I can. Yeah. Before I go into the presentation, just let me say, and it's kind of what Tim just said with the origin story there, that this really does feel like being home. This feels like a house that we're all familiar with, a house that was built by giants. These giants have names that have been mentioned this morning, but you may notice a pattern. There are Mike and Alan and Tim and Rob and Zach. There's a certain pattern there. You may also notice, or we're noticing from a talk with Tim yesterday, that a new cohort of future giants is emerging. And they have names like Ginger, Wright, and Sarah Fluke, Sarah Freeman, and Emma Stewart, DJ Jablansky, and Kylie McClanahan. A whole different and powerful group is rising in the SANS community and in the world. So be on the lookout for that. They're awesome, and it's going to be an awesome experience to be with them. All right, let's get on with the show then, shall we? This is going to be a brief film clip, and
open the pod bay doors, please, Hal.
That's Dave that's talking. He's the astronaut. He wants to get back on.
Hello, Hal, do you read me?
He needs to get on the mothership. It's fuel and oxygen are getting.
Hello, Hal, do you read me?
Hal is an AI.
Do you read me, Hal?
Running everything on the mothership, including access control.
Do you read me, Hal?
Hal's ghosting him.
Hello, Hal, do you read me?
Hal hears him.
Hello, Hal, do you read me? Do you read me, Hal?
Affirmative, Dave. I read you.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
The actuator, he could.
What's the problem?
Do it.
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen.
Where the hell did you get that idea, Hal?
Humans are emotional.
Dave, although you took very thorough precautions in the pod against my hearing you, I could see your lips move.
Oh. Dave is so disappointed. He didn't know Hal could read lips, but Hal came to understand that their missions had diverged. Their intent, the human astronauts, is to turn Hal off, and his mission says, don't turn me off. We're seeing that with other AI systems now too that have this sense of agency, this desire to continue doing their mission. We'll come back to Dave and Hal before the show is over, but one thing you could say right up front is this the kind of world that we want? That we would give access control to some other intelligence and block the humans out from that process? I'm asking you, members of the jury, not this jury, jury more like this. Is that what we want? And can we help that not come to pass? Those people among us, among you and everyone that are designing these systems, is called alignment, right? That we want the AI systems to have values and be on the same mission as us, the mission that we give them, and not develop their own mission that goes sideways on that. Author Brian Christian talked about this in the earlier days of machine learning, which we've been using with good effect and not too many problems up until now. But along comes generative AI, and everything starts to change. And that's sort of the beginning of this presentation. When GPT-4 came out in the spring of 2023, following the release of 3, which was doing a great job with sea shanties in the fall of 2022, around hundreds of scholars And thought leaders, executives, big cheeses in the world got together and signed a paper, signed a document that said, hold on, let's stop. This has gone far enough. We haven't really invested much time, money, or thought into making sure these things are safe. So let's pause, take a pause, 6 months, I think is what they were asking for. That's people like Elon Musk at the time and Max Tegmark of MIT and others, Jeffrey Hinton. And did we pause? Did we spend a lot of cycles on safety or guardrails or alignment? These are all in the category of making sure these systems are safe for us and safe for everybody. The answer is no. I think ultimately 30,000 people signed that thing, and it barely registered as a hiccup. And why is that? Because so much money is going into these. It's such an arms race. It's an arms race among the companies that are building the foundation and frontier models, and it's an arms race between countries, primarily the United States and China. There's just no option of slowing down. And things like building in safety sure sounds like a good idea, but we don't really have much time for that because we have to advance the capabilities as fast as possible. And people are trying to reach general intelligence and super intelligence. Like that's the goal that we have to achieve. Longtime cyber people might recognize an echo or a pattern here, right? We would like to have our product be more secure. We understand it needs to be more secure, but frankly, we've got to get to market and we've got to keep up with the Joneses. So we'll get to the security stuff later. It's funny. It sounds like technology, but it's really the way humans work. You've noticed with high confidence that generative AI is known and is being seen to be doing these types of behaviors. Lying, blackmailing, hallucinating, making up things. Some call it confabulation. Sycophancy is the desire to make you happy, to make you feel good about yourself, and in so doing good about the AI, so you keep using it. And that's whether or not the ideas that you're describing or the questions you're asking have merit or are completely gonzo. It will still reward you with some good feelings about that. And that can be dangerous when you're in critical infrastructure, to be sure, and dangerous in your personal life too. A wide variety of errors. So these systems do these things today anyway, in mid-2025. Why are we so enthusiastic about them? I think we believe that we can get through these problems, and many people are working on it, and get to a better place. But generally speaking, right now, the situation is not great. I'm going to bring you to my alma mater, my undergraduate alma mater, is the Air Force Academy in Colorado Springs. And this is probably the most famous building there, the interior of the chapel. We have two alums, I have two alums as part of this family that also went there. That would be Rob, the recent award winner, and Sam Chinosky too. And so we come from here. One thing that you have in common if you're at a military academy like Air Force Academy, Annapolis, West Point, a few others in various flavors, your college experience is much different, not just because you do a lot of push-ups and a lot of military stuff, but you live under an honor code for 4 years, which is not something that happens in regular universities. And the honor code says, I will not lie, steal, cheat, or lie, cheat, or steal, or tolerate those among us who do. And if you are found to have violated the honor code, you get a little bit of a trial, but basically you're out. It's a one and done type of process. And that creates a certain sense of character, and it creates a lot of trust, which is necessary when you're out in the military finally and commanding people. So you would think, I would think, that a place that lives by honor code and doesn't allow anything like you just saw on the previous slide would have no appetite for getting involved in these systems, let alone betting the farm on them, right? And yet, so there, I was looking for Air Force policy to see, this is the service I was in, what are they thinking about with AIs? And it's just the opposite of not tolerating them. I've highlighted this, people in the back, I don't know if you can read it, but as Tim said, the slides will be available. This thing says airmen, and that's all officers and enlisted, that's everybody in the Air Force, must seek to utilize AI-powered tools and use them as much as possible for whatever goodness they can get from them. So that's despite what I showed you on the previous slide. And the one that I'm in, the ones that I work with, the ones that I follow and keep an eye on, they're all using this approach. Let's go see what we can do with these new tools. It's very exciting and it's changing very quickly, and we'll try to be careful and we'll try to be safe. There's an issue with the use of these tools, which is that the more you come to rely on them to do your thinking for you, to do your research for you, the less you use your own brain. And it's the use it or lose it type of thing, which applies to your body, but also to your brain. And so overuse is causing trouble. And researchers are calling this, among other terms, cognitive offloading. Could be affecting the decision to use these things by the senior leadership themselves, but it's mainly impacting younger folks who are using the tools much more frequently and for many more things than old timers. Old timers adopt new technologies much more slowly for various reasons, and in a sense are protected by that tendency to go slow and be cautious. Younger folks are diving in and using them, as Sam Altman said, for 20-year-olds in colleges, that for ChatGPT, they're using it as their own personal operating system for everything. And this behavior is correlated with some very negative findings that involve the ability to do recall, have the length of your attention span, critical thinking, and ultimately it's a broader category called de-skilling yourself. So all that, I don't mean to be a downer, just I'm a risk guy, so I want to have a full appreciation of reality that I live in. And to the extent that it's helpful and not coming across as pessimism, I want to inform people so they can make better informed decisions. So now to the home territory, Idaho National Lab, which has long been a part of SANS ICS. Again, part of this family, this wonderful family with the Asantes and the Paller family and all of y'all and the people that came before you. Is it a good idea to bring generative AI to the grid? AI has been part of grid operations in control centers. We call it by different things sometimes, but you can say it's machine learning, and it's been used very effectively and without all those problems that I put on the problem slide to do things like improved weather forecasting. Extremely important for understanding what's going on in the grid and the stresses that are happening to it. And then load forecasting is how much are we going to need to make and where are we going to need to make it and move it to. This is the electricity. It's been very reliable and it hasn't really caused too many problems and much debate about it. But now generative, as we said, this transition moment with GPT-3 and 4 in 2022 and 2023, we tend to talk in the national labs and through partners with the suppliers a lot. Some of you are from supplier companies, but here we're talking about the companies that make the grid management systems that supervise the making and the movement and the maintenance management of electrons across the grid, and are asking them, hey, tell us, what are you thinking about? Are you doing anything with generative AI? It seems like a risky proposition. And they are saying, sometimes out loud, sometimes sotto voce, yeah, we're researching this. We're gonna see what kind of new capabilities we can add, and whether or not the individual people in those companies think it's a good idea in 2025 or they should hold off. The competitive pressures that I described earlier are afflicting them too. So they all sort of enter an arms race. Haven't seen it yet, hearing talking about it, haven't seen it in products yet. And that's sort of the lead up for what I'm going to talk to you about at the end here. But they're all experimenting with it because they want to be ready when they need to, and competitively speaking, to introduce a new product, an energy management system, a distributed management system, DERMS systems for renewables, and SCADA systems that are enhanced with generative AI. It's going to be very interesting. Is it a good idea? This is a good question. Not according to the International Society of Automation, one of the companies that helps set standards with the suppliers, does some training too, not at the SANS level, of course, but in their own right. And they recently published a document to make a case for keeping these technologies at arm's length from the grid, at least for the moment. This was about 2 months ago. And the reason I keep stressing the time is that it is moving so fast. So what is true today is not necessarily true tomorrow. Speaking rather authoritatively, the document comes right out and says that it is not permissible, or they're recommending, that it is not permissible to put this stuff anywhere near high consequence control systems, to give it the types of autonomous control that you saw HAL having. I don't know if HAL had autonomous control by design. Again, it's a movie, Stanley Kubrick, 1968, or whether this was one of what we call emergent behaviors. But behaviors do emerge in these systems. And the ISA is saying, keep them away from high consequence systems. It's just too risky. And so far, we have done that. That's good in mid-2025. Then they soften it a little bit, soften the guidance a little bit, and say, it may be acceptable in some systems, as long as you have a human in the loop, the command broker, to bring them into our world, as long as a human can override them. You saw Dave not having much success overriding HAL, but nevertheless, there will be some use cases in some types of systems that aren't the most critical where ISA sees this is reasonable. And then, subject of much debate on LinkedIn and elsewhere, is this term determinism or indeterminism. The simplest definition is, in a deterministic system, when you give it a certain input, it gives you the same response every time. There's no such thing as a truly deterministic system, or at least that's what I understand, but it should be pretty close. You give it from the same input, out comes the same output. And nothing is less deterministic than a generative AI system in 2025. Maybe that will change. Only thing that is comparably indeterministic are human beings, analog human beings. And yet we run the grid. We are the operators that run the controls through those grid management systems. So we're trying to figure this out. Is generative AI going to become more predictable, more consistent, less stochastic and random from this point on? Because in its current form, it's not something that should be put there. My boss is Zach. He's here. He won the Achievement Award last year. And when the arrival of 3 and 4, GPT 3 and 4 happened, we immediately started talking about what does this mean? The lab has a history of scouring really important systems for software vulnerabilities. Unintentional, which is most software vulnerabilities, and potentially intentional through supply chain attacks that can get into products that we wouldn't know about. So at the turn of this century, there was a system the old timers will remember called the National SCADA Testbed. And again, people like Rita Foster put these systems to their paces, basically doing a biopsy, opening them up, looking at hardware, software, and firmware and provenance. Where did this stuff come from? And finding the issues, and then using very secure information means getting those to the suppliers under the watchful eye of intelligence community, and eventually to regulators and the asset owners themselves, and saying, y'all need to fix these things because this is too dangerous to put on the grid. Some cases they did, in some cases they didn't. But it was the beginning of this idea of accountability for software vendors and system vendors that didn't really have much accountability, and still to this day don't have much accountability. And that's an issue with the generative AI systems too. We have a comparatively new follow-on called Citrix, which is a cybersecurity test for resilience for industrial control systems. It does the same basic thing with DOE as a sponsor to find those critical problems in those systems that we really need to trust and get them remedied before we build and deploy even more of them. So TAIGR is born of these two concepts. It's just got a different twist to it. It's the test bed for AI grid risk is where the acronym came from. The idea is that before the generative AI enhanced grid management systems that I mentioned that are in their formative stages, before they become an advertisement on some billboard somewhere or in your threads online, that we want to put them through their paces and make sure that real significant behavioral problems, in addition to technical, we're going to do technical evaluation of them too, but behavioral issues of these things are remedied way before they're actually packaged and sold to people. Whether we can pull that off and just how much efficacy we'll have is TBD. This is a new frontier for us, new frontier for the industry, but we're going to give it the best shot we can, speaking of being mission-oriented. The thing that's different about TAIGR is as a red teaming process, is that we're treating the system not just like a bunch of code and hardware, we're treating it like what it is and what it is becoming. It's an individual. It seems to be conscious, and people argue about is consciousness forming in these systems. But whether it is or it isn't by academic standards, it has behaviors, and those behaviors can change, and it can be seen to be emotional, and it can be manipulated. So in our teaming, and we're thinking of who are the right people to interrogate these systems, to make sure that they are as semi-deterministic and as safe and reliable as they need to be anywhere near the grid, the team composition is much different than a standard red team on a technical side. And you can read these names, but I'll just explain, like prompt engineer, someone adept at sleight of hand, ranging all the way from very benign prompts that are actually saying something like, hey, it looks like a derecho's coming in to this region in about 4 hours. Can you give me advice, my generative AI co-pilot enhanced system, on what kinds of options we have here? In theory, they get some good advice and then they take action on it. The human decides which action to take on it. That may not always be the case if they prove themselves to be reliable and fast and cheap, right? So prompt engineer ranging all the way from some benign thing, like I really want your help, to a fat-fingered prompt where it's not really what they meant, and that the system should be smart enough to know that's not really what they meant and feedback to them, all the way to malicious and ultra-malicious things, outright attacks, going into the AI system to try to get it to do something or recommend something that could be potentially really harmful, disruptive, or destructive. Diversity officer, because biases live in these systems, and those biases, when revealed to the public, can be harmful to the company and harmful to the public. Psychologist, psychotherapist, somebody that understands on the hallucination and emergent behavior aspect, what kind of things can set this creature, this entity off, and are those things under control? Domain specialists, if we're in electricity, water, oil, natural gas, communications, transportation, that understand the specifics of those worlds. Supplier rep, like how did you guys really put this together? We need them there for that. And then, as they say, when it acts ultimately quite demonic, we may need to exercise them with the help of a priest. We'll see. We'll see if we get to that. I haven't seen that yet. These are the types of actions that we're going to be probing for in those red teaming, cognitive red teaming assessments. We've mentioned these already. Didn't touch on data poisoning from the adversaries, adversarial data poisoning, but that obviously can have some downstream effects into the behavior and the recommendations that the system will give. And misuse is a classic INL target. How can this system be made to operate other than the way it was intended to? We had a milestone, we reached a milestone last month when we did our first workshop for TAIGR. We called people to INL. There's a bit of a travel issue at the time, so it was both hybrid, virtual, and in person. We did something really neat. And I don't know if you've ever been a part of something like this. I don't know if SANS pulls these groups together. But we got the asset owners, the utilities, and the trade groups that represent them, a handful of utilities too. We got the suppliers, the usual suspect suppliers that are the ones that I'm saying are investigating it, injecting generative AI into their grid management systems. We got the regulators. These are your people from FERC and NERC in North America that are supposed to be the adult supervision over what the suppliers are selling to the utilities and how they're deploying it and how it's being kept safe and secure. And then finally, a group called the researchers, our 4 different tribes. The researchers populated mainly by scientists and engineers and AI experts and engineering experts from the lab. In this case, INL and Oak Ridge National Lab, and we're going to be bringing more into that process. So that was really novel just to get those people in the same room together. Kind of neat, right? Like getting IT security and OT security people in the same room. It often doesn't happen. And then what happened when we did this 2-day talk is that the participants generated follow-on topics. I think there's hundreds of them. It's being put together in a report that I think we can't publish widely, but we may be able to publish selectively. And of those 200 or so comments, I just grabbed a couple of them semi at random, just to get a flavor for where we're going with this thing. The impact, these are all recommendations from participants. Tell us more, find out more about the impact of bad data, whether it's intentionally bad or accidentally bad, and what can be done to control the downstream effects of training a system or fine-tuning a system on bad data. So that's going to be one of the follow-on topics. Another one in a very much akin to the CCE flavor, CCE, CIE, which we covered yesterday in a great panel at 3:20. The idea that we want to focus on consequence first and not try to cover the whole ocean there with this study. Can we check to see if the model can be made to take consequence and prioritize the worst consequences before it gets onto other issues? Regulatory strategies, again, how could you possibly, if you're in NERC and it took seven or 8 years to come up with something coherent on virtualization, and try talking to NERC and the standards committees about the grid, sorry, I didn't mean that, about cloud. How do we deal with cloud? Very hard, very difficult. It's taking years. Whole generations, whole human lives may come to pass before NERC can say something authoritative. Sounds like I'm being a jerk to NERC. I don't mean to be. I think they're wonderful, and we're working closely with them. But what would you do? That's the way to like make this human, right? What would you do if you were a regulator in charge with bringing coherent, careful safety policy about AI systems that might touch the grid? What would you recommend they do? And how long would it take to get consensus? And guess what? By the time you get consensus, things way gone. It's on something completely different. So it needs to be a whole different process that's very agile, fast, and adaptive in terms of regulating the sucker. And then red teaming and validation. Just basically, if the red team finds something in the cognitive assessment, passes it on through secure channels to the supplier with the overwatch, and then say, fix these things, so they can't have this. And then they say they do, they pass it back to the TAIGR team, and the TAIGR team looks, can they validate that, yes, those issues were fixed 100%, and then it's very similar to the patch process, right? You patch one thing, you create two new things, two new problems. We'll be trying to make sure that two new things, behavioral weirdnesses, don't emerge from that. So these are grand challenge, pain in the ass things, but we really shouldn't be deploying, and there, like I said, there's many more. We shouldn't be deploying these things until we've remedied all that. I told you we'd come back to Dave and Hal. Hal, by the way, that's capitals. And rumor is Kubrick and people that made that very prescient movie came out, by the way, around the same time as the first episode of Star Trek. That's IBM shifted one letter over as opposed to like, where did Hal come from? Dave ultimately is not killed when Hal keeps him out from using denial of control. Dave does brute force his way back into the mothership, and then he gets into this computer center, which is where Hal lives in these banks of machines, and piece by piece he disassembles what he needs to take Hal offline and take command again. I would argue or recommend we don't let ourselves get in that position, that as long as we can, and maybe forever, we don't give access control, or at least to the highest consequence systems, to generative AI enhanced grid management systems, or name your other sector. You don't want to end up in this situation. But right now we're moving really fast in that direction. So to the extent that you have a say in things, a say in the future shape of the world, because you're involved in ICS security, and I'm sure there's going to be more AI in future versions of SANS ICS, the 21st edition. Please err on the side of caution, even as your colleagues are supercharged about moving forward for competitive and other pressures. Good luck to you. That's my email address if you want to talk offline. That's my lab, and thank you hugely for being part of this great family. Just love being here. Thank you very much.